Okay, I want to say a few things about quantum mechanics and determinism. Now, there's this view called compatibilism about freedom of the will, which says that you can have a free will, something we'd call a free will anyway, still have determinism in nature. I believe something like this, except for it depends what you mean by determinism. I mean,
My position would, I suppose, best be characterized as hard incompatibilism. It doesn't matter to me whether we live in an entirely deterministic universe or reality, uh, or partially. Either way, you can't have such a thing as free will. To me, free will, the term, and I suppose this all boils down to how you define these terms, but free will is nonsensical. The way I see it mainly used is as sort of a justification for a very absolute ethical outlook that says no matter what circumstances you find yourself in, you are equally responsible for your actions, basically. So there's no such thing as a mitigating factor, say. And I just don't see that as being a very good system because to whatever extent we live in a deterministic universe, our decisions are more than just our own. There's two things going on, whatever is happening internal to you and whatever is happening externally. So you have an interplay there. That's why we do have a will. I would agree that we have a will, but our will is not the sole determinant in what the outcome is. If you have two people that are identical in their will and you put them in two different circumstances or two different scenarios and expose them to different environments, then you're going to have a different outcome. So you really can't judge any action in a vacuum, and that's what I see people trying to do when they talk about free will. So in that sense, like I said, I'm a hard incompatibilist. If you want to define away the free part of will and just stick with will, then you could call me a compatibilist.
things are partially determinable, so there's that. But an actual determinism, I guess I tend to not believe in that. I tend to not be able to describe myself as determinist. But, I do believe there's things you can figure out. Okay, now, part of this issue that comes up as well is that, QM introduces randomness. QM doesn't introduce randomness. Nature is random. QM is understanding the randomness in nature, and what you use that understanding to overcome the randomness. So you do amazing, almost magical things. You can pull electrons from orbits that they shouldn't be able to be pulled from. You can have quantum cryptography and quantum computers and stuff. So it's about mastering that stuff.
All right, I'm not sure what your expertise is with quantum mechanics. To me, my understanding is that the problem quantum mechanics presents to determinism is that it introduces the idea of acausal events, which would undermine determinism. Determinism is predicated on the idea that all events are causal in nature, and if that is true, then there is an unbroken sequence of cause and effect, such that no matter how many there are, no matter how many causes there are, no matter how complex it is, if it works out in a deterministic way, then the outcome is set beforehand, basically.
Another way somebody put this compatibilism was that a belief in determinism doesn't mean a belief in pre-determinism.
Yeah, I don't understand how anyone could argue that perspective because, like I said, I think that the two really are interchangeable, determinism, predeterminism. They're equivalent concepts. I mean, determinism is stating that prior events are the only cause to current events. So there's a perfect reversibility in that in cause and effect sequences, which would also mean that there would be that events would be perfectly predictable if you could account for all factors.
Now, I believe in something. If I believed in determinism, it'd be some kind of which you could say that. It didn't imply predeterminism. Okay, the many histories interpretation of quantum mechanics is deterministic, but in this sense, right? Because when you roll the dice and it comes up 7, the fact that it came up 7 was determined by the fact that you rolled the dice, the shape of the die, all of those regular classical features determine that. It's just that it could have turned up a 5, and then the 5 would have been determined by that. Anything that comes up was determined by that, and all the things that couldn't come up, say 14, we got a 14 Those are excluded, and again, the deterministic aspect has to do with what is excluded from the set of possibilities. But it doesn't exclude all but one. It never will exclude all but one. There will always be more than one possibility.
Okay, what you're describing here is a very superficial analysis, I suppose, of what's going on when you roll dice. There's more involved than simply the number of sides and the fact that, obviously, the fact that you throw them in the first place is a necessary condition for having the event occur in the first place. But there's more going into it than that. I mean, you can mathematically describe a probability of rolling any given number, if assuming you have weighted, non-weighted dice rather. But there's a lot more going into it than that. And all we're talking about here really is Newtonian mechanics. We're not even introducing quantum mechanics, which would be possibly acausal. What we're talking about is a very large number of factors. It's a complex system, but the more factors you can control, the further, the better that you will be able at predicting the results. So if you can take into account such factors as, say, the force that you throw the die, the force at which you throw the die, the size of the dice, so, I mean, that's like air resistance, the wind in the environment, the rotational velocity of the dice as you throw them, the trajectory they're traveling in when you throw them, the distance from where the dice are released to the table, not only just the simple geometric shape of the dice, but as we know, all dice are pretty much, they have irregularities and they're also not perfect cubes, so they have rounded edges. To whatever extent they're rounded, that will come into play. The angle of incidence that they strike the table at is going to be important. The composition of the dice, so how powerfully they're going to rebound off of a given surface, what kind of surface they're hitting. I mean, if you can control these factors, you should be able to, if not predict perfectly, at least narrow down the probabilities so that it's no longer a perfect representation mathematically that it would be if it was an entirely random event. So, I mean, say if I were to engineer a robotic arm so that I could perfectly predict the action, I could set the dice into the whatever the holder is for this arm in a very specific way, and I could situate that robotic arm relative to the table that it's going to hit or the surface that it's going to roll the dice onto exactly, and I can control these factors, and I would be able to theoretically predict what is going to happen, because like I said, all we're talking about is Newtonian mechanics. I mean, it is a fairly complex system. There's much more complex systems out there, but that's the only thing that limits our ability to predict the outcome, not the fact that it's a non-deterministic event.
Okay. So, then why are you calling that determinism? In what sense is that determinism? Because there's regularity and patterns in nature? That's the way I think of it. I would say, oh, I'm patternistic. I believe there's patterns in nature, including non-deterministic patterns. Okay.
Well, why do you think patterns arise? Patterns arise specifically because we're talking about a deterministic relationship here. And the only reason we observe patterns and speak in terms of patterns is because we don't have a perfect understanding of complex systems. There's simply too many variables to take into account, and we may not perfectly understand all the causal relationships that are involved. And I mean, basically, what patterns represent is we understand the starting point to some extent. We can measure it to some extent, and certain ideas about it, and then the end event, or the end result of whatever system we're talking about, or whatever series of events we're talking about. I mean, yes, when you change the starting conditions, it's going to change the ending conditions, but there still be a pattern because certain causal relationships and certain constants are involved. That's why patterns arise, not because there's no other reason for patterns to arise. So I don't see that as a non-deterministic thing. That's just a lack of certainty or a lack of complete understanding of what's going on in any given system. Like I said, complex systems are very hard to account for, so that's why we relegate our understanding to, or that's why we're forced to stop at patterns rather than a complete